Alright, so this will be another practice video, so I'm just going to practice real quick and go over, see if I can explain this, and if I even understand it by explaining this. It'll help me understand it. I honestly don't think I'm at the level where I can, actually really help anybody else with this. But okay. So anyway, so I'm going to do is solve this problem, pseudo-palindromic paths. So to do this, I learned some bit masking techniques, and also the main strategy is basically you're going to use this observation, use the observation that what a palindrome is. So use the observation that a palindrome can only contain a one odd occurrence, or not like that. What I'm going to do is I'm going to use an integer. I'm going to use an integer. So actually no, I'm not going to use this. So I'm going to use one integer to store the information that I need. So for instance, my integer will be maybe something like this, where actually I do need paint for this, because what I'm going to do is my digits can range from 9 to 1. So we have 9, 8, whoa, that was a bad 8, and 6, 5, 4, 3, 2, and 1. Those are the digits that we can have. Now we can represent this with one integer in terms of binary representation, you can think of it. So for instance, I will initialize, or I won't have to initialize it, but we'll just say, everything is like 0. And one thing to realize is that a 0 represents a matched pair, or no pair at all. Matched pair or none. But the important part is that if we get a 1, that is an unmatched pair. So this is like a Boolean or flag thing, I guess. I don't know if I even understand that completely, but yeah, so like basically if it's a 0, it's a matched pair, or it's not a matched pair, but that doesn't matter. If it's a 1, it's an unmatched pair. And the observation for a palindrome is that you can have at most one unmatched pair. So using that observation, the observation was that you can have at most one unmatched pair. We can use some bit masking. So the bit masking techniques that can be implemented here is, first off, we can use the XOR. So XOR will basically work in the sense of allowing us to set something equal to 1. So when we get like our root value, we need to take that root value, say if it's 5, and set it on here. But I think root 5 is going to be 0, 1, 2, 3, 4. It's our fourth 0 starting from the left. Here. So since this is our fourth 0, I'm going to subtract 1 and then take this 4 and do this value, whatever this is, so we could call it C, and we'll do C XOR with 4. And what that will do is it toggles. So the fourth element in here, which is 1, 2, 3, 4. Oh my god, I messed this up. Wait, what? What did I just do? Oh, okay. Wait a second. This doesn't make any sense. My fourth element is 4. Okay, I think I know why. If I recall, I think it's because this is 0 indexed. I guess I'm going to test this out in my code. This is really bad, but yeah, I think this is 0 indexed. So when you go to the fourth element is actually, this is 0, 1, 2, 3, and 4. So this is actually the fourth element. And so it'll toggle this and it'll set it equal to a 1. So that gives me one unmatched, and then we might get other ones as well. So for instance, we could have 0, 0, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we could have that, which means that unmatched pair at 5. And then what we need to do is then we need to be able to check. We need to check and make sure, check if something has only one unmatched pair. Now this is easy as well because there's another technique where you can use your value, whatever I said, C, and do -1, and then when you do -1, if you had, this has to be equal to 0, and you want to do AND with your original value, because you want to check. So when you subtract 1, it will look for the least significant one, I believe. I think that's how it works. It'll look for the least significant one, which is this one, and it'll set everything after it equal to 1. So you'll get like 0, 0, 1, 1, 1, 1. And then if you do the AND with that, and your original value was 0, 0, 1, or if you AND this with this, and you're checking, you're going to get 0. So if it's equal to 0, it's basically telling you that you don't have this, but it's basically telling you you only have one unmatched pair. However, if you were to have another one over here, so you have 2 unmatched pairs, when you did this, this one would stay out there, and it would not equal to 0. It would equal to, because when you do AND operator, it will check these, and AND usually is used for extracting subsets. So, so you'll get something like this, which obviously is not equal. Oh my god, this is so bad. Not equal to 0. Okay, whatever. This is just scrabble. So yeah, so with that basic algorithm, I'll code it real quick then. So basically, we want to create a DFS search, and we'll search through our roots, and we'll set our count equal to none, count equal to none. No. I want my count to initially be equal to 0. And then in here, if not root, return 0. Else you want to do count, and I said exclusive OR with root.val -1, and then I'll do in my DFS search, I need to do DFS, my final result will be equal to DFS root.left, where my count is, plus DFS root.right, the count. Ultimately, you want to return res. There's one other thing you need to do. If root.left, this is going to be the check if you had a leaf node, because the root.left and root.right will both be none, which is equivalent. Then when you want to do this, the subtract, you want to check that there's only one unmatched pair. Let's see if I know how to do this. Count and count -1 equals 0. Then you want to increment res by 1. Yeah. I also need to call this return DFS root. I don't need to do count because it's not a positional argument. So yeah, does this actually work? Oh, I don't need this anymore. I don't need this. This is really bad. What did I do wrong? Invalid syntax. Oh, this should be if. Okay. Yeah. Okay, it looks like it works on this case. I'll just submit Alright, yeah, so this doesn't work, and I know why. It's because I messed this XOR up, or exclusive OR, whatever it's called. So I'm going to clear up some space on this, because it looks like, yeah, this is not completely correct. You have to, you set your 1, and you left shift it by 4. That's what you actually want to do. If you left shift your 1 by 4, it will give you something like that, I guess. And if you have that, and you're doing the toggle button, it will toggle this 1, which has 4 zeros. It'll toggle that 1, and you want to do that. So that means I have to do 1 left shift by this, and yes. Okay, so yeah, so you can see the count. I'm printing out count just to see what happens at each of my leaf nodes. So like each of my leaf nodes, the count is 2, 6, or 3. Now I can tell based off of this which ones have only 1 unmatched pair, and the 2, when the count is 2, that means you have only 1 matched pair, because that corresponds to a 1, 0, right? Because at the first 0 on the starting from the right side is of course 2 to the 0 power, and the 1 is 2 to the first power, which is 2. The 6, though, the 6 is obviously in binary form something like 110, I believe, because 4 plus 2, and you know, like this is 4 and this one's 2 and this one's worth 1, because it's 2 to the whatever. Anyways, that's really bad, but yeah, so that's 6. So this one obviously won't count, and 3 won't count as well, because that's 1, 1, where you have 2 and 1, and that's 2 unmatched pairs. So those are not palindromic. So that's how I was checking if it's palindromic. And also you can even check the results. I can print res. Just print res. Oh wait, I already finished this. Why am I still, or I kind of finished. But anyways, yeah, this is really bad, but okay. I tried doing this, but yes, it didn't come out that well. I messed up, and yeah, but I'm gonna keep learning. How do I stop this? Yeah.